Let's begin by discussing the subsets of real numbers. Subsets of real numbers outline. By completing this section, you will be able to determine if a given number is irrational or rational, and categorize rational numbers into subsets. Definition: real number. A real number is a number that is either rational or irrational. Any common number from negative infinity to positive infinity is a real number. Definition: irrational number. An irrational number is a number that cannot be written as the ratio of two integers. For example, pi is an irrational number. Example: irrational number. The decimal approximation of an irrational number does not terminate or repeat. Examples are shown in the table. Pi, radical 2, and radical 123 are all examples of irrational numbers. Definition: rational number. A rational number is a number that can be written as the ratio of two integers, where the denominator cannot be 0. For example, 1/2 is a rational number. Example: rational number. The decimal equivalent of a rational number will terminate or repeat. 1/2, 3/8, and 2/5 have decimals that have a finite number of decimal places. They are called terminating decimals. 1/3, 2/7, and 5/6 have decimals with digits that repeat to infinitely many decimal places. These are called repeating decimals. Note: a line over decimal digits indicates those digits repeat infinitely. Subsets of rational numbers. There are three important subsets of rational numbers. The set of natural numbers includes 1, 2, 3, and so on. They are used for counting and ordering. The set of whole numbers is formed by adding 0 to the set of natural numbers. The set of integers is formed by adding the negatives of the natural numbers to the set of whole numbers. Venn diagram: rational numbers. The subsets of rational numbers are shown in the diagram. The set of natural numbers is a subset of whole numbers. Both natural numbers and whole numbers are subsets of integers. Natural numbers, whole numbers, and integers are subsets of rational numbers. Note: integers as rational numbers. An integer can be written as a ratio by putting it over 1 in a fraction. For example, 3 equals 3/1. Stop and think. Subsets. -7 is an element of which of the following sets? Real numbers, irrational numbers, whole numbers, or integers. -7 is an element of the set of real numbers and the set of integers. The next section will discuss some of the rules for dealing with real numbers. Rules for real numbers outline. In this section, You will gain knowledge of the double negative rule, rules for adding and subtracting real numbers, and rules for multiplying and dividing real numbers. Double negative rule. For any real number x, negative negative x equals x. Example 1. Negative negative 5 equals 5. Example 2. 7 minus negative 3 equals 7 plus 3, which equals 10. Addition rule. Like signs. When adding numbers with like signs, add the absolute values of the numbers and keep the sign. Example 1. 8 plus 5 equals 13. Example 2. Negative 8 minus 5 is the same as negative 8 plus negative 5. Both expressions equal negative 13. Addition rule. Unlike signs. When adding numbers with unlike signs, subtract the smaller absolute value from the larger absolute value. Keep the sign of the number with the larger absolute value. Example 1. 9 plus negative 7 equals 2, because the larger value of 9 is positive. Example 2. 1 plus negative 4 is the same as the opposite of 4 minus 1. Both expressions equal negative 3. Note: adding a negative number. Adding a negative number is the same as subtracting that number. For example, 6 plus negative 2 is the same as 6 minus 2. Multiplication rules. The product of two negative numbers is positive. The product of two positive numbers is also positive. The product of a negative number and a positive number is negative. Example 1. Negative 2 times negative 3 is 6. Example 2. 2 times 3 is also 6. Example 3. Negative 2 times 3 is negative 6. Division rules. The quotient of two negative numbers is positive. The quotient of two positive numbers is positive. The quotient of a negative number and a positive number is negative. Example 1. Negative 8 divided by negative 2 is 4. Example 2. 8 divided by 2 is also 4. Example 3. Negative 8 divided by 2 is negative 4. Note: commutative property. Addition and multiplication are commutative. The value of an expression does not change when the terms are reordered. Example 1. 8 plus 1 is the same as 1 plus 8. Both equal 9. Example 2. 3 times 4 is the same as 4 times 3. They both equal 12. Stop and think. Sign rules. Match each expression to the left with its evaluated form to the right. Use the double negative rule to find negative 12 equals 12. Use the addition of unlike signs rule to find -7 plus 3 is -4. The product of two numbers with unlike signs is negative, so 4 times -5 results in -20. The quotient of two numbers with unlike signs is negative, so -21 divided by 7 is -3. Use the addition of numbers with like signs rule to find -5 minus 4 is -9.